Mobility is an increasingly urgent issue nowadays. Growing numbers of people want to, and indeed must, become even more mobile. But this growing demand for individual mobility is now rapidly overloading our traffic systems. The solution, which has always been obvious but is set to become more incontrovertible than ever, is public transport, relieving the pressure on our roads and environment as it does. But LVK is going a step further. Our goal is modern transportation which helps protect the environment, using the emission-free energy source of hydrogen. That is the future of public transport. It's a big step, and one which can only succeed if resources are pooled by the companies involved, policymakers and local authorities. It all started in Hürth in 2005, when the regional innovation network HyCologne set itself the target of making intensive use of hydrogen as an energy source. The presence of the local chemical industry there meant that conditions were ideal. For the industry, hydrogen is a byproduct which is already available for reuse and cheap. Fuel cell hybrid buses are not yet standard products, which is why the HyCologne partners have invested so much effort in the last few years and carried out tests on different platforms. And here finally is the result. May 6, 2011. In a national press conference, LVK's first fuel cell hybrid bus was introduced. Attended by a large number of both local and national political and business VIPs, the maiden voyage started at the central bus station in Hürth. But it was quite a long way to get there. Production of the first fuel cell hybrid buses for LVK began in 2009. APTS, Advanced Public Transport Systems, based in Helmond in the Netherlands, is located in one of the main centers of automotive development in Europe. The bodies and technology of the vehicles are given tangible form in the computer. Here the buses are being planned and designed right down to the finest detail before actual assembly begins. This is how it all starts. The body shell. The bodies look like this when they're delivered and are then fitted out to order. Intelligent production management and perfectly coordinated logistics allow certain processes to be carried out in parallel. This reduces construction times and increases efficiency. Like any other vehicle, the fuel cell hybrid bus requires basic electric cabling. Everything is checked and tested in line with the specifications. But this is where the first difference becomes apparent. The tanks. For the hydrogen. For the fuel which provides the energy, but with zero emissions. Here too, safety is the top priority. This is why the hydrogen tanks and tubes are subjected to special 435 bar tests by the German TÜV Safety Standards Authority, 1.5 times their rated value. It looks like a simple, inconspicuous black box, yet it's the heart of the entire energy system, the fuel cell. The energy stored in the hydrogen is converted directly into electrical energy here. And these are the components of the fuel cell. First, the anode, which the hydrogen is fed to. And opposite, the cathode, to which oxygen is fed. Between them is a membrane. Finally, there's an appliance which consumes the resulting electricity. If hydrogen is now fed to the anode and oxygen to the cathode, an electric current starts to flow, which can supply electrical energy to an electric motor or can charge up the bus's batteries. The key advantages of this reaction are that the entire system is 5 times lighter than batteries and that nothing other than pure water is created during the generation. Now the energy generated needs to be put to work by means of an intelligent energy management system. The energy management system has been developed by a high-caliber research joint venture between the Cologne University of Applied Sciences and RWTH Aachen. The bus's entire electric drive system has been faithfully reproduced here in Cologne, so that all the technical details can be specified and tested with maximum precision. All the typical test cycles for daily operation of the bus are subjected to rigorous checks. Once everything has been optimized, the software is uploaded to the bus where it's ready for use on the road. Batteries and high-performance capacitors, or supercaps, are fitted alongside the fuel cell to provide power. In a normal bus, the kinetic energy generated during braking is converted into usable heat. The Phileas, by contrast, has special brakes, which can turn the kinetic energy into electrical energy each time the brakes are applied. The current is generated in a similar way to a dynamo and can then be used when the bus sets off and accelerates. The supercaps are primarily there to take care of the peak loads. The batteries are responsible for the mid-range load for normal driving situations. The fuel cell functions like a baseload power plant, recharging the batteries and supplying current for short-term storage. Coordination of the individual components in the highly complex energy management system demands maximum vigilance from all concerned. Setting up, taking measurements, checking, comparing values, final programming. This is the moment everyone has been working towards. All parts of the drive technology are now working together. The air conditioning is also mounted in the front section of the roof alongside the battery and the control technology, ensuring a pleasant temperature in the passenger compartment, which is what's now being completed, putting the finishing touches to the electrical cabling, the doors and the locking system, and for safety's sake, the emergency exit. At this early stage of construction, you can see just how this 18-meter-long bus manages to negotiate even the tightest of bends. The articulated joint is what makes it possible. The driver's cab is now finished too, the command center of this highly complex transport system. It's been a long journey from the first computer drafts through to the first test drive. This groundbreaking and pioneering project was made possible by a unique partnership between the Netherlands and North Rhine-Westphalia and by close collaboration between the businesses and research institutions involved. All working towards one goal, that of creating clean public transport with low noise emissions and no harmful emissions whatsoever. Tomorrow's technology today, turning a vision into reality. Hydrogen, the emission-free energy source of the future, being exploited already today. RVK's first fuel cell hybrid bus.